Okay, so I guess I can start. Thank you everyone for attending. I will try to be clear, but don't hesitate to ask questions or stop me if I am not, because obviously English is not my first language, but I will do my best. Yeah, and today I will talk about what we did in the lab team with the registry service and taking our first step in distributing our compliance artifacts in a probably unmodified way using IPFS. So why IPFS, and what is IPFS? I guess most people already know this, but it will be fast. So IPFS is a peer-to-peer protocol designed for storing and sharing data in a distributed file system. It's based on Cademlia, so it's a DHT, and most people, I guess, used it 10 years ago when using stuff like Emule. So it's a peer-to-peer protocol for sharing files. And unlike traditional web protocols that locate data based on server with location-based addressing, IPFS locates data based on its content, which is important because this means in practice using a SHA hash to address files, and this is useful for us because then we can basically guarantee that the file accessed is the file that we served. The advantages of IPFS, so decentralization, I've put some words here and here because we will see on the next slide, but in our case, we do not eliminate completely this, but IPFS usually eliminates reliance on centralized servers and reduce points of failure. So it increases resilience and censorship resilience and outage resilience. The efficiency and performance, so this also is a bit will have to be a bit explained for our use case, but since it fetches the files from the nearest node, it can potentially speed up the content delivery. Permanence, so this we benefit fully. Content addressing, so through CIDs, ensures that data cannot be tampered. Interoperability, this also we benefit from because since the content becomes available on IPFS, then everyone can fetch it and use it however they like. So they will not have to specifically rely on our APIs or stuff like this. Cost reduction, this can reduce hosting and bandwidth costs, but we will see later that in our case, maybe it won't be so much cost reducing. So in the GX DCH context, the potential cons of using IPFS to provide the registry artifacts. So in order to really eliminate the reliance, the point of failure, and increase resilience, we will need actors, GXDCH service operators, to participate by pinning and sending our artifacts. So this will be important because you can, at the moment at least, use you will be able to use, because we are speaking about the next version, but you will be able to use and deploy, use our services and deploy the services as a clearinghouse without fully configuring IPFS to provide the file and seed the files. So if we are and when I say we, I mean the association, the only one sending our artifacts, then obviously we still are a point of failure because, as we will see later, IPFS is not incentivized. IPFS nodes are not incentivized to share our content. So yeah. IPFS can be slow if we have a low number of peers. So this is mitigated by the same thing that I just said. So the fact that GXDCH operators should configure the service to be a peer. We are also introducing a new external dependency in our registry service deployments in the form of Kubo, which is the reference implementation, at least the implementation, the most used implementation of IPFS. Also, since both are communicating both the registry and the new service that I will be presenting later are communicating and the Kubo node, are communicating through the standard RPC API of Kubo. Any compliant IPFS implementation, even externally hosted, would work. So if, let's say, for example, I'm a GXDCH operator and I don't want, for whatever reason, to manage and host this Kubo service, I can pay a small fee to whatever company providing IPFS services and call their APIs or any other API, RPCI API for IPFS. And on small text-based files like ours, the trust framework shapes and revocation lists and so and so, the cost of exposing an IPFS node IP or DNS through load balancers on a cluster will probably be greater than centralized hosting bandwidth cost. So this is referring to this. In our case, maybe the cost reduction won't happen, but we are talking about a few euros per month to expose the public IP, but still there won't be as much cost reduction or even a small increase. What changed and didn't? So the impacted artifacts are the trust framework shapes and schemas, issuers revocation list, and trusted GXDCH list at the moment, at least. Previously, those files were either bundled statically on each registry service instance or served from our GitLab, and then they are served through the endpoints of the registry through the API to other compliance service. Now, at least in the next version, those files are retrieved both on startup and at regular intervals at runtime from IPFS by the registry instance, and then they are still served through the same endpoints. So this won't change. We have a new Gaia-X IPFS service, which is called the IPFS pinning service. This new service is managing our compliance artifacts through IPFS pinning and seeding. So in order to serve a file on IPFS and have it stay on the network, you have to pin the file regularly and ensure that it's not garbage collected by the nodes. So this is one responsibility of this service. It's the new place where we'll be updating and unit testing the trust framework shapes. This was done previously inside the registry. And now this new service becomes the central point for those shapes. The service also advertised the root CID, so the content ID, which is basically a hash of our artifacts to registry services instances by leveraging our OctoDNS configuration. So I've linked the project, but OctoDNS is, I guess it's quite known, but it's a way to manage DNS as code, DNS configuration as code. And we will see later that we are using DNS text field to provide and advertise at least the root content ID of the artifacts. And this service will not need to be hosted by GXDCH because for now we are the only one that need to the association are the only one that need to update the trust framework shapes and revocation list, but this can change in the future and we will see how. So a deeper look. This is the second diagram on how this all work. So let's start by the pinning service. It queries the IPFS record txt field on our gxdch.eu DNS, which is a domain that is controlled by the association and configured by OctoDNS. It computes locally the local CID content ID of the sum. Let's say it computes the sum of the hash that represents the sum of the files that we are serving in IPFS. And if this hash is the same that is currently advertised on the gxdch.eu domain, then it does nothing else. It does this at startup. And it's deployed automatically by our CI. If, however, the CID that it has retrieved from gxdch.eu is different from the CID that it has computed locally, then this service will have to update both the artifacts, update, at least provide the new artifacts on IPFS and update the txt pointer on the domain so that the registry instances can then fetch everything and the previous files, which are public, so we don't care about this, but the previous file will be eventually garbage collected because they are not pinned anymore regularly by the pinning service. So to update the txt pointer, we clone the OctoDNS repository. Then we update the configuration of the text field. And we provide and pin the compliance artifacts that are addressed by this new content ID. So this is only on the association side. On the GXDCH side, the registry services regularly queries the IPFS record text field through a simple cron job inside the node service. Then it does the same as the pinning service at the beginning. It compares the record with the local CID of the artifacts. And it queries the new artifacts if needed. So this is done at the moment, if I'm not mistaken, every 10 minutes. So that ensures registries services will serve the correct artifacts whenever we decide to update the trust framework. Or the revocation list, which I guess will be updated more frequently, or at least will need to be up to date. And then finally, it provides those artifacts through its APIs in the same way that was always done to other GXDCH services like the compliance. Looking forward, so this is weakly distributed and not decentralized. Although we are leveraging technologies that are distributed like DNS and decentralized like IPFS, we are still updating those in a dictatorial and permission fashion. And some of those artifacts could probably benefit from more decentralization, namely the revocation lists. And yeah, at the moment, we are the only one that are in control of the domain and the keys on GitLab and are able to update this. IPFS as a protocol does not incentivize sharing by non-involved parties. So that was what I was mentioning at the beginning. This means unless we use paid services, which we don't, will only be as distributed as the number of seeding JXDCH. So this is where we will rely on the operators to seed the content. It's still okay because the size of the artifacts is very small and they are not queried a lot. And this scales with the GXDCH deployment. So the GXDCH are the one that queries those artifacts, but they are also the one that become a new peer on the network as soon as they are up and running. So this will probably never be an issue since everything should be linear on this side. Other part of our infrastructure are still fully centralized, notably the credential event service. So this service, which is at the moment only deployed by the association, but advertise the verifiable credential that we signed and provide them. And this service is still fully centralized. It was running on the Kafka, and now it's a database, but still. Potential solutions, so DAOs, governance, and voting mechanism. There are a lot of options that are allowed by smart contracts that could allow us to update artifacts in a decentralized fashion. So those solutions can be very simple, like multi-signature contracts, and they can be more advanced, like DAOs and voting systems, stuff like this. They could use voting tokens, and we are not talking about tokens that you could speculate on or even transfer. That could be tokens that the members get or the operators get, and they use them to vote. So this in the future could be discussed and could be a solution to this dictatorial and permissioned update of artifacts. And regarding the CES, much like NFTs, we could very well put in place a solution that combines some transaction data that's inscribed on a smart contract and points to IPFS to provide VCs in a decentralized fashion and distributed fashion. This could be complicated because it needs to be cheap, it needs to be fast, so that, for example, catalogs can retrieve them easily. And the complexity of the potential complexity of using blockchain's solution to power this should be abstracted and basically invisible to consumers. So Yeah, we would need to think more about this, but there are solutions like L2s, application-specific chains, and for example, what Delta DAO is doing. The community is encouraged to provide feedback, ideas, and concern on this because this is still very much in discussion and in research phase. So yeah, and also feedback on how this first step looks to you if you have any. What will so basically to deploy this new infrastructure, nothing really changes for GXDCHs because this is managed by so the new deployments are the ping service, which is only deployed by us, so this has no impact, and the Kubo deployment, which we have included in the Helm charts of the registry. So you would only have to update your configuration with Helm update. But if you want to have a fully functional Kubo deployment, which means a seeding Kubo deployment, you would have to have some exposed public IP or domain so that the node is addressable by the IPFS network. If you don't, and let's say in the future you only deploy the new version of the registry and do nothing else, it will still work. Everything will work on your side, but you won't be helping solve these concerns, which is not a huge issue because we will be, of course, always seeding those artifacts, but still, it would be the nice thing to do. So yeah, we do not expect GXDCH to have any additional workload about this. Only a choice, which will be probably a choice on whether or not your security policy allows you to expose one TCP port and one UDP port. Yeah, which will be routed to Kubo. And if you need more info, as always, we are available on Slack. We have mailing lists. Most of us are there every Thursday on the OSS community call. You can contact me directly, or you can raise issues or merge requests on GitLab, as always. And yeah, I guess we have 5 minutes if you have questions on anything.
Just a little question. When you're talking about the Octo DNS repo, it's a Git repo?
Yeah.
Yep.
Yeah, it's a Git repository that's on our GitLab, and this one, I guess, unlike the others, we are the only one that will ever push changes to, but since we are in control of the domain.
And it auto deploys when you do a commit or whatever?
Yeah. Yeah,
Okay.
Evan made sure the CI auto deploys the configuration changes. And so if you, well, I personally will not be making a commit. It's the pinning service that will directly do it, but yeah, it will automatically update the DNS.
I have also a question. Thank you for the slides and your presentation, Arthur. I have a question. Why is it not possible, or why is it request chaining necessary? As a provider who runs a digital clearinghouse, I have to connect to the registry, and the registry asks to the EPFS master. Is it possible to go directly to the EPFS master?
Well, yes, if you, I'm not sure I understand correctly, but if you mean, can I directly retrieve the compliance artifacts from IPFS using the content IDs? Yes, you can.
Yeah. Okay. Okay. Great. Thanks. That was my question. Thank you.
Yes, Olivier.
Yeah, I was wondering, do we have enough traffic, enough loads to justify adding such a dependencies? Why just fetching file from a Git repository, which guarantees that you are fetching version file, is not good enough?
So firstly, we previously some files were fetched from the Git repository, but some files were bundled statically, and so this would mean that you would serve whatever files that was bundled with the registry, which could be tampered with. Here we basically everyone that will be fetching those files with the content ID will be sure that this is the correct file, and yeah, because it's addressed by the hash. So I guess this is the main advantage, and also if GitLab is down, well, it still works. But yeah, you're right. We have not. We are not serving a lot of files and a lot of data, but still, it does eliminate a point of failure, which is GitLab.
And I will add that the fact that we were not pulling a repository, we were using GitLab APIs or HTTP servers to retrieve files from GitLab, which is quite something that we wanted to remove. Yeah, finally, the fact is that we want to move towards a decentralized and with a consortium maintenance of those files, and using GitLab would not be the proper way of doing it. So that's a step forward with this decentralization and yeah, consortia driven maintenance of the files.
Okay, thank you. Maybe one more questions. How do we ensure that this distributed file system is secure enough so it's not tampered with and it's not being used for other purpose?
Which file system? IPFS?
Yes.
So IPFS is pretty battle tested, I would say, because it's existing for a few years already. But basically, you can compute the CID of the file yourself. You are not relying on necessarily on any library. So this is cryptographically secure, I would say, and we still, on the security front, we still have to make sure that we are in control of our DNS, but yeah, DNSSEC is activated, but I'm not sure what is your concern on this.
My concern is not about, security of the code. My concern is security of the access to these things, because, if somebody can gain access to it, he can use it for, I don't know, sharing video, music, and all that kind of crap. So how do we ensure that, security,
So he will be able to, in your let's say, in your scenario, if someone gets access to your Kubo node and use it to share stuff.
Well, we are exposing, a TCP and a UDP port to expose this IPFS, right? Okay, so if somebody...
to seed, but not to provide files on the network.
On the network. Well, if you are seeding, you are providing file, right?
Yeah, but your node only has the files that you've added to it. So it provides whatever is on his file system, which has been added by the registry service, but not. You cannot use those ports to tell the Kubo node to provide more files. This would have to be done via another Kubo API that we do not open on this deployment.
Okay. Okay, I want to make sure that the system is tight. I think that's going to be important.
Yeah, I understand, but I think it's pretty tight. But if you have specific concerns, please tell me, and I will try to address them in writing.
Okay.
Is there any more question, remarks, concerns regarding this IPFS decentralization and step forward?
So if we move forward with this, it means the next version of will have to use IPFS, so all provider will need to handle it, right?
In fact, it will be bundled with the Kubo that will access the IPFS storage to retrieve the files, but you are not forced to be a seeder, which means you are not forced to open yourself with a UDP to seed the file. That's two different things.
Okay, and what percentage of provider do you expect needs to be seeder for this to be stable? At least 3, I would say.
The most possible. At the moment, the association is the only one using a Kubernetes cluster that is on OVH infrastructure. But yeah, I would expect like some of, I will say you because you are from OVH, but I would expect some of the GXDCH to accept being seeders. Otherwise, that's quite well stupid to do this, and we'll probably just go back to calling GitLab through HTTP, and we just abandon our sovereignty there and say, okay, too bad.
Okay. Good. Thank you.
Thank you.
Okay, so we are a bit late. If there are no other questions, and if there are questions, please send them to me on Slack or GitLab. I will be happy to oblige. Thank you, everyone.
Thank you.
Yeah, thank you.
See you in the OSS call, and have a nice afternoon.